Good morning, HOD professors, A.K. Chaturvedi sir, my seminar guide Shantilal Meena sir, seminar coordinator D.P. Sharma sir, faculty members, examiners, and my batchmates. I am Nikita, pursuing my B.Tech from University Department of Mechanical Engineering, Rajasthan Technical University, Kota, Rajasthan. I am here to present my seminar presentation on recent development in rapid prototyping. Introduction to rapid prototyping. Rapid prototyping, also known as additive manufacturing, refer to the layer-by-layer fabrication of three-dimensional physical model directly from a computer-aided design. Development by Japan's H. Kodama and America's C. Hull. The RTU processes provide a fast and inexpensive alternative for producing prototypes and functional models as compared to the conventional routes for part production. The advantage of building a part in layer is that it allows you to build complex shapes that would be virtually impossible to machine. In addition to the more simple designs, RT can build intricate material structure, parts inside of parts, and very thin wall features, just as easily as building a simple cube. Let's move to the next slide. Need of rapid prototyping. Until the 1980s, companies wanted to control their production costs and ensure product performance. It was necessary to test products without expensive tooling and in a much shorter time than with conventional techniques. In the 1990s, the concept of quality appeared, which required the use of prototypes to validate the quality criteria of the product. Finally, in the 2000s, companies wanted to be the first to launch a new product on the market, which requires an extremely short design development process. This influenced the development of machines and technologies for producing prototypes more and more rapidly. Next slide. Basic steps in rapid prototyping involve creation of a solid model, then converting this model to STL file format, slicing the file, then creating the final product. In the last, post-processing is done, which includes cleaning, curing, and finishing. Next slide, please. Types of rapid prototyping technology. There are various RP technologies available. Few of them are stereolithography process, laminated object manufacturing process, fused deposition modeling, selective laser sintering, and shape deposition manufacturing. Next is first step, stereolithography process. It is most widely used rapid prototyping technology introduced in 1988 by 3D Systems. A highly focused UV laser to trace out successive cross sections of a three-dimensional object in a bed of liquid photosensitive polymer. As the laser traces the layer, the polymer solidifies and the excess areas are left as liquid. When a layer is completed, a leveling blade is moved across the surface to smooth it before depositing the next layer. The platform is lowered by a distance equal to the layer thickness, typically 0.003 to 0.002, and a subsequent layer is formed on top of the previously completed layer. This process of dressing and smoothing is repeated until the build is complete. Once completed, the part is elevated above the bed and drained. Excess polymer is swept or rinsed away from the surface. Next slide, please. The next process is laminated object manufacturing. This process, RP technology, where the build material like paper, polymer, metal laminated in the form of adhesive layers are fused together and then cut to desired shape with a knife or a laser. A roller rolls on the build material, presses and melts the material adhesive. A microprocessed laser cutter is moved in XY coordinates to cut the layer on the basis of the virtual cross-sectional STL layer. Once a layer is processed, the platform is brought down vertically by the length equal to the layer thickness. A new laminated sheet is pulled on the carriage and then reprocessed. The manner is repeated so as to achieve the final product. Moving to the next slide. Next is fused deposition model. The name itself gives the idea that the parts are formed by deposition of the fused material in layers. The RP technique is used in modeling, prototyping, and the production applications. FDM was developed by S. Scott Kraft in the late 1980s and was commercialized in 1990s. In the FDM process, a gantry robot which is fitted with the extruder head moves in XY directions The table moves in vertical Z direction when a layer gets deposited on the table. It goes down according to the layer thickness and the subsequent layer are built in the same way. In order to build complex shape paths, FDM uses support material apart from the build material which supports the overhanging structures during the process and helps in maintaining structural integrity of parts until it is strengthened before the support material is removed by breaking or by dissolving using appropriate solvent. Next is selective laser sintering. It is a commercially new technique and is used for manufacturing of small stock components, though various sectors are approaching the technique as there is an enhancement and development in this domain. SLS printers use high power laser, for example CO2, to fuse powders into a 3D shape. The laser selectively fuses powders material on the powder bed by scanning the cross-sectional generated from the CAD data. The powder bed is then lowered by one layer thickness after the scanning of each layer is done. A new layer of material is applied on top and the process gets repeated until the desired structure is achieved. The SLS printer preheats the bulk powder below its melting point to make it easier for the laser to increase the temperature of the selected region beyond its melting point. Next is shape deposition manufacturing. It is one of the developing RP techniques wherein simultaneously fabrication and assembly of mechanisms is possibly done. The SDM printer uses two different materials, a primary material which constitutes the finished object and a supporting material. The supporting material is laid down as a base for a final material. The final material is then laid on the top of the base. CNC machining is done and the process to mill the part to the desired shape. The surface is then cleaned and prepared for the next layer of material. The process is repeated until the final layer is achieved and the support material is removed. Next is advantages and disadvantages of RP process. In advantages, it is fast method of prototyping, design and ideas, multiple design iteration, physical validation of design, reduce product development time and cost, reduce material wastage and no tooling needed. In the disadvantages, shrinkage and thermal warping, model size limitations due to size of printer casing, need post-processing, limitations in the range of suitable raw materials. The next is applications of rapid prototyping. Rapid prototyping technology is used in various fields. It is used to make patterns for sand casting, investment casting, and injection casting. It is also used to make custom-made parts, wind tunnel models, functional prototype, dies and molds. In medical field, it is used to create prosthetic parts and also customized surgical implants. Next is recent development in rapid prototyping. The first one is custom-made COVID-19 face mask. COVID-19 is a global pandemic. The virus spreads through respiratory droplets and close contact. Therefore, the availability of personal equipment for healthcare professionals is essential. COVID-19 is a global pandemic. The virus spreads through respiratory droplets and close contact. It is essential in 3D printing technology could represent a valid option to ameliorate PPE shortage. Custom-made face masks were designed on the basis of facial scan and the 3D printed. 6 healthcare workers wore this device weekly, thus expressing a judgment regarding quality of work, respiratory and skin comfort. The estimated total cost of the single mask is approximately 400 rupees. Custom-made masks are novel and useful devices that can be used in the fight against COVID-19. The next is the threadboard. E-textile, which is embed circularity into textile fabrics, blend art and creative expressions with engineering. Currently, e-textile developments relies on tools intended for traditional embarked systems, which utilizes printed circuit board and insulated wires. These tools do not translate well to e-textile, which utilizes fabric and uninsulated conductive thread. This mismatch of tools and materials can lead to an overly complicated development process of novices. In particular, rapid prototyping tools for traditional embedded systems are poorly matched for e-textile prototyping. The threadboard, a tool that supports rapid prototyping of e-textile circuits. With rapid prototyping, everyone can test the circuit design and identify circuit error prior to their SIM project. The next is medical implants made by rapid prototyping. This technology plays a significant role in reverse engineering applications, e-manufacturing processes, rapid tooling, product design and development, medical field, medical education and training, designing and development of medical devices, designing of the customized implant, scaffolding and tissue engineering, prosthetics and orthotics, mechanical bone replica, forensics. Various problems are solved in dentistry by implementing this additive manufacturing technology. AM system provides extensive support in medical applications, providing better accuracy, speed, product visualization, and customization. Customized tools, improved modeling, and extensive assistance in decision making. Additive manufacturing is opening up a new market to help the humanity. Next is innovative design of a helmet based in reverse engineering and 3D printing. Based on reverse engineering, product innovation design and 3D printing technology, a technical route for the rapid design and development of helmet products has been constructed and optimize the product production process, reduce the product development cycle, improve production efficiency, and complete the personalization design of helmet to improve the comfort of personal wearing. Next is 3D printing of cultured meat. Production. Three-dimensional printing is a fast-developing digital technology with colossal market scope in food and nutrition technology, providing a platform for establishing unique food products with enhancement sensory and nutrition value for a particular end user. Cultural meat is the concept of producing meat sustainably in laboratory conditions without the sacrificing of animal life. The excessive use of antibiotics, 3D printing would offer unique solutions for the vital issues of cultural meat production, particularly on regulating the protein, fat, and the nutrition content. Along with providing realistic texture, this review highlights the immense benefit of 3D printing technology for the scalable and reproducible production of cultured meat products. Rapid prototyping is aiming revolutions in the way companies design and build products. As of now, there are various developments being done which will later help to bring a drastic change in the manufacturing methods. These are the references which I have taken from the internet for my research. Any questions, please?
Fast prototyping methods can be used for hardened part.
You can use metallic AM processes such as 3D laser cladding or powder bed fusion and then do a heat treatment.
Which software is good for rapid prototyping of products for manufacturing?
Any solid modeling package like NX, Cassia, SolidWorks, you can use for solid modeling of parts. For STL reprocessing, you can use Materialize Magic software. Thank you everyone.